All right, a permutation is an arrangement of objects in which order is important. It is very important. So something has to come first, second, and then third. A factorial is written with, it's an exclamation mark. And it is the product, or that means multiply, of all positive numbers less than that number. So the formula looks like this, although this left-hand part doesn't necessarily matter. The biggest part y'all need to remember is that it's n factorial over n minus r factorial. And n is the total objects. So whenever we're doing part over whole, that n would be the whole, and the r would be the part. So that's the sample objects. And I know that y'all have been learning a lot of different types of probability, but for the test, all this is going to be separate. So you're not going to have to remember which word problem is a permutation, which word problem is independent, which word problem is dependent. All that will be separate whenever you take your test. So you don't have to remember which is which. You'll just need to remember how do you do a permutation when given one. Okay. So, but what factorial does, let's say you have 4 factorial. That means that it is 4 times 3 times 2 times 1. So factorial means that you take that number and you multiply all the ones after it, down all the way down to 1. So 13 factorial would be 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's all that factorial means, is short way of writing all that. So it says that there are 6 friends who will pose for a picture, but only 4 friends can fit at a time. What is the probability that friend 1, friend 2, friend 3, and friend 4 are chosen in that order for the picture? So all you really need to get from this is that n is 6 because that's the total, r is 4 because that's the part. So whenever we write this and plug it into our formula, it's 6 factorial over 6 minus 4 factorial. Well, 6 minus 4 factorial is 2 factorial. So the way that we easily get rid of these factorials so we don't have to list the entire thing is you make the top one count down until you get to the bottom one. So what I mean by that is it will go 6 times 5 times 4 times 3, and then the bottom is 2 factorial, so we stop there. And then we have 2 factorial. So this and this cancel, because the thing that's the same on top is the same on bottom, so you can cancel it. So in our calculator, we don't have to put all of that in there. We just need to do 6 times 5 times 4 times 3. Which gives us 360. So our probability will be 1 over 360. Which would also be, let me see, 0.0028 or 0.28%. A student's identification card consists of 4 digits selected from 10 possible digits from 0 through 9. So there are 10 possibles and there are 4 digits to make it. find the probability that a randomly generated card has the exact number of 4, 2, 1, 3. So all that means is this is giving you the exact order. Remember, I told you order is important. So 4, 2, 1, 3 is not necessarily important as far as solving the problem, but it is in telling you that it is a permutation because it has to be done in this order. So our n is 10 and our r is 4. So it will be 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial, which is 10 times 9 times 8 times 7 times 6 factorial, all over 6 factorial. Those cancel. So in your calculator, 10 times 9 times 8 times 7. 50/40. So it is 1 over 50/40, or 5040. Okay, whenever you have something that looks like this e to the negative 4 means you're going to move this decimal place over 4 times to get your answer. So since it was 1.98, that's the same thing as times 10 to the negative 4. So in scientific notation, just like you do in science. So we're going to take this decimal place and we're going to move it over to the left 4 times. And then we can forget about this stuff on the right. So it goes 1, 2, 3, 4. The decimal place is now there. So our decimal is 0.000, and we're going to round it to 2 because it's 19, so that 1 will round up to 2. So that is the same thing as 0.02%. And on permutations, you will have very low probabilities like this, so you will have to round to 4 decimal places. It's the only way that you'll be able to write a percent. Okay, next we will have repetitions of permutations. And it's when an object is repeated 2 or more times. And that formula is n factorial over r1 factorial, r2 factorial, rk factorial. And these r's are the repetitions. And the n's still the same. That's like your whole. So that's your total objects. Okay, so it says, on a game show, you are given the following letters and asked to unscramble them to name a U.S. river. It is selected, if you selected a permutation of these letters at random, what is the possibility that they would spell the correct answer, M-I-S-S-I-S-S-I-P-P-I? So, there are, if you're looking at M's, there's only one of those, so they're not repeated. I's, there are 4 of those, so that is your R1, because those are repeated 4 times. If you're looking at your S's, there are 4 of those, so that is your R2, because those are repeated 4 times. And then your P's, there are 2 of those, so that's your R3. And your total, so 1 plus 4 plus 4 plus 2 is 11, and that's your n. So what you're going to write is 11 factorial all over 4 factorial times 4 factorial times 2 factorial. The easiest way for you to solve this is to do your 11 down to 4 factorial. So you'll do 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. So that will automatically take away one of your 4 factorials, The other 4 and 2 you need to write out to cancel. So it'll be 4 times 3 times 2 times 1, and then your 2 factorial. So 2 times 1. So in case you kind of got lost there, this 4 factorial is here and it's canceled with that other 4 factorial. This 4 factorial is here. And then this 2 factorial is here. So that's where all that came from. Now we can cancel things out. Automatically, anything over 1 is just itself, so the 1's canceled just by being there. 4 times 2. 4 times 2 is 8. And then 3 times 2 is 6. So those can cancel. So in our calculator, we just got to do 11 times 10 times 9 times 7 times 5. Because we canceled all those other things. So in our calculator, we're just doing these 3, 7, and 5. Because those are the ones that did not cancel. 11 times 10 times 9 times 7 times 5. So that's 34,650. So our answers, 34,650, all over under 1. And if we put that into a decimal, it'll be some crazy insane decimals. So if you do 1 divided by 3,4,650, you have to move this decimal place over 5 times. So this 2 can be rounded to 3 because of this 8 after, so this is 3. And we got to move this decimal place over 5 times. So it'll be 1, 2, 3, 4, 5. That's where the decimal is. So your decimal is 0.12343. And then in percent, that is 0.003%. Those are your answers for that one. Okay, the next one is, what is the probability of 7 digits, so out of 7 digits, telephone number with the digits 5165215, so those are the ones that we get to pick from, is this exact number. So whenever we look, out of the 5s, actually let me just go in numerical order, it's easier for me that way. So out of the total 1s, there are 2 of them, so that's my R1. Out of the 2s, there is only 1 of those, so that is not repeated. Out of the 5s, there are 3 of those, so that's my R2. And out of the 6s, there's only 1 of those. Those are not repeated. And that is a total of 7 numbers, which is my N. So it's 7 factorial over 2 factorial, 3 factorial. So we need to write our 7 down to 3 factorial. 7, 6, 5, 4, 3 factorial. And we have our 3 factorial. We still have our 2 factorial. The 3 is canceled. And our 2 factorial is 2 times 1. So again, if you kind of got lost, my 2 factorial is here. My 3 factorial is here. The 3's canceled. And the 1 automatically cancels because 1's canceled. If we want to cancel the 2, we can cancel it with the 4. How many times does 2 go into 4? That leaves me with 2 left over. So now in our calculator, we just got to do 7 times 6 times 5 times 2. 7 times 6 times 5 times 2. 420. So 1 over 420, which is 0.0024. which is 0.24%. Okay, you may have to re-watch this a couple of times if you didn't pick it up the first time. In fact, you might want to go back to a specific problem and re-watch that same problem a couple of times until you might get the hang of it. This is kind of complicated, which is why I'm making a video over it. Plus, my 5th period needed it anyway because I won't be here on Wednesday. But feel free to re-watch this a couple of times until you get the gist of how it was done. It may take a while, and this is the only week we have tutoring, so if you need it, come in.